Right, we're doing some homework review questions for Honors Algebra 2 Pre-Calc. This is the Chapter 4 review homework during our COVID-19 closure. I am on page 346, number 131. Okay, so it's a word problem. From city A to city B, a plane flies 650 miles at a bearing of 48 degrees. Okay, so when we talk about bearings, right, we need to know our compass directions. Never eat slimy worms or soggy waffles or sour watermelon or whatever, right? So a bearing can either be something like north, 20 degrees east, which means face north and turn towards the east, or north 30 degrees west, which would mean face north, turn to the west, etc., right? Or south 20 degrees west, which would be south, turn 20 degrees towards the west, whatever. Or it can just be called a bearing of, and in that case, we default to north, turn to the east. So, city A, right? I'm going to put a little never eat slimy worms at city A. This is city A. I'm going to face north and turn 48 degrees to the east, right? So that's going to be like this direction, and I'm going to fly 650 miles, right? So this measurement is 48 degrees, right? Then at city B, I'm going to turn and fly 115 degrees, at a bearing of 115 degrees, I'm going to fly 810 miles. So that means face the north, turn 115 degrees is going to mean all 90 degrees of quadrant 1, and then also 25 degrees into this quadrant, right? So 90 and 25, right? And I'm going to fly 810 miles, so 810 miles, right? I'm going to land at some city C, right? Terrible at drawing, but you get the gist, right? So I'm going to land at city C. And then I don't know the bearing. I don't know if this angle at A is acute or obtuse. I don't know if C is actually here or down here. It's hard to know, just so it's not drawn to scale. And they asked me to find this physical distance from A to C, and also the bearing from A to C, meaning what is this angle? And again, it could be acute if this is drawn correctly. It could be slightly obtuse if C is actually down here. But so those are the two things they asked me to find. So when we get to chapter 6, we're going to talk about labeling triangles like this. Where if I have angle A here, I'm going to call this side little a. And if I have angle C here, I'm going to call this side little c. And if I have city B here, I'm going to call this side little b. So essentially, what they need me to find is they need me to find little b. And they also want me to find this bearing, which is going to be whatever big A is, plus 48, right? So the two things that I need to find for my answer, I need whatever B is in miles, and I need a bearing of whatever 48 degrees plus angle A is, right? And I just don't know angle A yet. Now, angle A is not the 42 because we don't know that angle A goes down to the east line, right? So let's walk through this and walk through what we know. So since north-south is parallel everywhere, right? If this is an angle of 48 degrees, then this guy, alternate interior angles, must also be 48 degrees, right? Since I know that this is a 25, and this whole quadrant right here has to add up to a 90, this part right here, this piece here, must be whatever 90 minus 25 is, right? So that's a 65. So I get that this whole angle B must be a 113, right? 48 plus 65. So here's what I know. If I make a list of stuff I know that angle A is a question mark. I don't know angle A, right? I do know angle B. I just figured out that angle B is 113 degrees. I don't know angle C, right? Because again, although I can figure out what this is, I know what this measurement is based on this measurement, that's not enough because I don't know where this dotted line is. Is it on the axis? Is it below? Like, where is C actually located? And I don't know. So I don't know C. I do know little a. It's the 810 miles, right? I don't know little b. That's what I want for my answer. And I do know little c. It's the 650 miles. So right about when you get here, you start to say, wait a second, this is not a chapter 4 pre-calc problem, because it's not, and that's why some of you emailed me and you were like, whoa, this is tricky, because this is not a chapter 4 pre-calc problem, and that's what's making it hard. So the issue here is that this is a non-right triangle, right? We know it's non-right because it has an obtuse angle, and all of the trig that you know how to do so far, you know how to do with right triangles. So since this is a non-right triangle, and we can't easily make it into a right triangle, we need to figure out some other way to do this. So the way to do this is going to be using 6.2, which is the law of cosines, which you don't know yet, and that's why you're stressed about this problem. and 6.1, which is the law of sines. So, the reason that this is a law of cosines problem first is that you use the law of sines when you have a pair of things, like big A and little a, or big B and little b, or big C and little c. And notice that we don't have any pairs here. I don't have A and A. I only have one of the A's. I only have one of the B's and one of the C's. So I'm going to start with the law of cosines. And basically what the law of cosines tells me is if I want to find B, B squared equals A squared, the other side, plus C squared, the other side, minus 2AC, cosine of angle B. And those are all things I know. I know A, I know C, and I know big angle B. So B is going to be the square root of 810 squared plus 650 squared minus 2 times 810 times 650 cosine of 113 degrees. Now, make sure your calculator's in degree mode. Mine was in radian before this because I teach a lot of calc. So I'm going to type this guy into my calculator, right, and hit enter, and I get that B is approximately 1,220.671 or 2 miles. So that's my first answer, right? That's the first part of my answer. That's the distance between them. And then I'm going to hit stow and store that as B in my calculator, right? So this is a 1,220.671 or 2 miles, right? And then I'm going to store that as B. And the reason I'm going to hit stow alpha B, I picked B just because it was already B, is that I'm then going to use the thing called the law of sines to find, so what I figured out at the beginning, I needed to find A to find the bearing. So now I do have a pair. I know big B and little b. So now I'm going to do a thing called the law of sines. And the law of sines says that the sine of big A, which is the thing I don't know, over little a, which is 810, equals the sine of big B, which I know. Oh, sorry, I know that, so I can put a 113. 113 over little b, but remember, I stored that as b in my calculator, right? So it's this 1120, et cetera, et cetera. So if I solve for sine of a, right, I'd move the 810 over, and I'm going to get sine of a equals 810 sine of a 113 in degrees divided by the thing I called b, right? And so my a is going to be the inverse sine of that whole mess. 810 sine of 113 degrees divided by the thing I stored as b, right? And when I type that in my calculator, so if I do inverse sine, which is second sine, right, of 810 sine of 113, again, I'm in degree mode, so I don't have to write that, divided by alpha b, I get 37.648. So I get that A is approximately 37.648 or 9 degrees, right? But then my bearing isn't actually A. My bearing is from the north, turn both the 48 degrees and then whatever A is. So I'm going to get that the second part of my answer is that the bearing is 48 plus this thing that I'm going to store as A. So I'm going to get that the bearing is approximately 41 point, oh, that's not right. I added it to 4, not 48. Hang on. That was not right. That's not how math works. All right, that makes way more sense. 85.648 or 9 degrees. So that's the second half of my answer. Yeah, when you add 37 to a 4 and somehow or to a 48 and you don't get a number bigger than a 40-something, you know you added wrong. So the reason some of you have been finding this hard is because for some reason the book inexplicably put a problem that was above the level we've covered in here, and that explains why you found it stressful.